Okay.
That's horrible.
Okay. Share screen. Screen one. Cool. Cool. Let's see how fast I can do it today. So, as I was saying, leave. I'll deal with that email later. I added the lab, the assignment, and the week 3 lecture for this week. And in the syllabus, there is now a book, which is, you know, if there's ever anything I say that's like a little unclear, of course I will clarify, and I'm here. And just know that I get most of my source material from this particular book. So you can probably open this book, search for the particular thing you're having trouble with, and you get the source. You can get to the source of my madness. Also, in the homework, I'm trying to be better about stuff. So in the lab, I have like a basic step list that gets you ready for doing this this code here. And then I also provided a picture of the hierarchy of like make like a player and then a touch controller and a player cube root, and then you put a cube inside the player cube root for like animating it. This is to make that jumpy cube video I showed a couple weeks ago. And in the homework, I tried to be very specific about like what is in it, and then I provided examples of each thing I'm talking about. And then from that book, I provided an excerpt of the chapter that this stuff is from. So I'll talk about the assignment and all that after the lecture, just letting you know at the head of the recording, if people are watching, that I do have examples and all that stuff in the assignment this week, and I'll try to be better about that so that people have a little more clarity about what it is that I'm expecting. With that said, where is Zoom? So I'll make sure I'm not missing chats or anything, or people trying to get in. Actually, how do I verify that? Oh, more, yeah, chat. Oh, just Kendall and Joe. Okay. I assume you're saying that you saw Tron Legacy. I don't believe even I am old enough to have seen Tron in theaters.
My dad did, probably.
My dad would have gone like, "That's weird," and then wouldn't have seen it. My mom dragged my dad to a Led Zeppelin concert when they were first dating, and he was just like this grump. I can't believe mom stayed with him because he's just like grumpy jerk the whole time. What is this? He was like, "I like the Beach Boys."
Yeah. The thing with my family is that my mom married a geek and then had 2 geek children. She's the only normal one out of us.
I'd say my mom's probably the most normal. My dad has like a license plate that says PC Wiz and crap on it. Okay, so this week I'm gonna do like a quick overview. I'm not gonna hammer down too far into stuff, but I'm gonna talk a little bit about usability and feedback in games, and what I mean when I talk about those things. Because I'll probably my background is, I'm sure you couldn't tell, like user interface design. Surprise. So when I'm talking about making things fun, it often has to do with making things usable and making things have intuitive features based in how I interact with it. Because a game's only as good as how you interact with it. And then I'll talk a little bit about game design documents. Have y'all done game design documents for other classes? Is this like a thing that you're already prepared for?
Nope.
Okay. Okay. So I'll try to be quick about the game design document stuff. Oh, not really. Okay. Then I'm going to be excruciatingly slow about it. Not in depth. Cool. Okay. Well, my goal is to be better than that other Unity class in general, so I'm gonna try to do that. Okay. I'm at a good start. Where will I falter? Okay. So let's zoom through it. I'll be talking about usability and feedback. Those are kind of like interaction concepts. Then I'll be talking about game design documents because I need to lead into what I want for this week, which is kind of the thing that you have to think about before making the game design document. The homework this week is going to deal with pitching your group project game. Totally fine if it's something that's already existed, like in your homeworks of previous weeks. Totally cool if you want to do something different than what you've done in the previous weeks. Either way, you've got like 8 or like 12 weeks. This is a 15-week course, right? Oh yeah, it's fine, whoever it was. Um, so that is going to be what we talk about this week, and I hope to get back to, maybe I'll use the labs to primarily focus on some of the more technical aspects, and then use the lectures to focus on just kind of the high, like I got to make sure you guys know like some expectations about writing and some expectations about like the game design process and all that kind of stuff. I did see a lot of people having like Google Drive troubles over the weekend. I'm still thinking about the best way to like force the knowledge of GitHub into everyone's brains, but I'll keep thinking on that. Maybe I do like a sit down this week where I make everybody's GitHubs, and then I give everyone the information to access it. Maybe I'll do something like that. I don't know. Anyway, feedback and usability. This is the book I was mentioning before that is on our website. Don Norman is a really, really good book because he basically invented these concepts. So if you have any interest in design whatsoever, this book is a foundational book. I actually wouldn't be surprised if they already assigned it to you in other classes. But it's a really good book. The Design of Everyday Things. Game Feel, A Book of Lenses is also a good one. And Nielsen Group is just, they do research, so I probably include some research in here. Okay, so when I say feedback, it's a bit nebulous, but when I say feedback, I mean at some level, when you are interacting with something, a door, a game, anything, you provide some input, whether it's your hand on the knob turning, or whether it's a button that you've pressed. And either the mechanical system of the door interprets what you're doing and has a system designed specifically for that turn, or in a game, you've programmed to interpret whatever that input is, like, oh, that's the A button on the first person's controller. Then you modulate something in response, whether it's, oh, in response to that input, I am going to, it's connected to a series of gears that moves the little door dooble. I forget the name of it, so that you can open the door. Or, man, I used to know the name of that. It's gonna drive me crazy the rest of the class, and I'm gonna yell it in the last like 5 minutes. Or in a game, no, not the knob. The little, when you turn the knob and the thing that goes in the hole comes out when you turn the knob. This thing. It'll come to me later. Latch? No, it's not latch. Anyway. Yeah, the Double thing. Or in a game, when you press a button and it realizes that you've pressed a button and it responds, and you've programmed a response that says jump or show the menu, whatever it may be. It's some way of showing the user the response of what was put in. And the more complicated your system, the more important feedback becomes, because they need to know that a particular thing was good or bad to do. And I realize now I forgot to put in some additional content, but it's fine. When you provide feedback, you can help inspire them to do that activity again or not. Oh, when I walked into that wall in Mario, like little spikies, I got hurt, so I shouldn't do that again. Because you know, maybe at first I wasn't sure what those floors did. They looked different than normal floors. Or there's the mushroom that is green that poisons you and it shrinks you down, even though every other collectible in the game helps you. The feedback is what makes them know, oh, I shouldn't do that again. And you can have positive feedback, like all the good things in the game are also things you want them to do more of. And explaining these things to the user can be difficult because there's two models at work. I talked a little bit about this before. There's the system that you've created, the program model. Like this is what you've developed. Click, 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 click. And as I'm sure you've noticed when you program something, things look like they don't work, but they end up doing exactly what you told them to do. Like, oh, I had some typo in it, so it was doing exactly what it thought it should do, but you know, we just gave it the wrong information. So there's that specific way that the machine sees the world based on what you've programmed. And then there's how we are presenting that to the user. So the user, they don't know all the like random generation systems behind loot boxes in a game. They just know when I put money in, like something comes out. So that's a system where the user model is really distant from the program model, because the program model is doing all these specific math things to like make it as unlikely as possible for you to get something good. Whereas the user, in general, when they're younger, which makes it a little predatory, thinks that, you know, all the chances are the same. So that's a poor example of a user model matching a program model, whereas we as good developers want to make them kind of as close together as possible. We want the user to kind of understand how the system works so that they can have more fun. A good example of kind of the extreme of this is like the speedrunner culture, where speedrunners try to understand the program model as much as possible and like understand what makes it tick so that they can manipulate it and you know, shave 5 seconds off of the time. Less than, usually it's like half a second off the time, just because they know that, like I don't know if you guys are familiar with Little Nightmares 2, which just came out. I just saw some insane skips in it just because they realized, oh, I don't need to bring the stool over. If I jump on 20 things and then jump at the door, I can grab the door and pull it down without having to do anything else, just because I know how the system works and that it's really just, is the hand close to it? Doesn't have anything to do with bringing the stool over. Old Spyro speedrunners. So the program model, it's just whatever you put in, it's just whatever you program, so it's not going to change. But different users, when they look at this model, are going to think different things. Some people will love the game, some people will hate the game. Some people understand the systems, some people won't. Do I want to talk about modulation response? Sure. Yeah, whenever you do something in a game, the way you usually want to think about it is it's kind of like music, where every note that's hit has an initial attack, has a sustain, has a decay, and then is gone. So modulating those different aspects, so how much it ramps up, how quickly whatever input you did ramps up. So when I hit forward on the analog stick, how fast does the user start moving? when I tap on the screen for Flappy Bird, how fast does it jump? Does it kind of lead into the jump, or does it immediately do it? And all of these elements influence how characters move in games, how characters swing their swords in games. Like, one of the interesting things about Dead Souls is a different game. Dark Souls is that there's a really high ramp up. The attack is really slow, every button you hit, but they all matter. They all string together. And they call it committing. You have to commit to what you've done. So they have a really big attack, ramp up to what they're about to do. After you've done it, it stays for a while, it decays for a while, and then it stops. So you hit something, and that has a very long payoff. Whereas other games like Super Mario, he all of this is super quick. It's the exact opposite. And they're both good games. Like, there's no wrong answer to how you respond to a user's input. Just depends on the feel that you're going for. And I know this is getting into the weeds, but this is how you achieve certain feels. I want it to feel like you're rolling a physical ball. Well, modulating how we do the feedback loop of moving with an analog stick is how you get there. Otherwise, you're not going to get there, because you're going to be, oh, when I push forward, it moves forward. What's the problem? Well, if you want it to feel like a certain thing, you have to understand how the feedback would go. How relevant that will be to whatever you guys work on, up to you. So putting feedback away for a second, now I'm getting to usability. When we talk about usability, there's sort of three aspects of it. There's actual usability, utility, and usefulness. Usability are, I'm just reading to make sure I'm understanding my own notes, because yeah, make sure, which one do I reference here? I think this is Nielsen Group, right? Yeah. Nielsen Norman Group. Okay, cool. Depends on which person made it for me to know which thing I should talk about. Okay, so when we talk about usability, we're talking about quality metrics that we've measured, that as a person's interacting with systems, as many people are interacting with systems, we're figuring out, oh, how did they mess up, and how can we improve it? So, for example, I'm thinking of I'm thinking about doors. I like talking about doors because there's so many different designs for doors. Have you ever pushed on a door that you were supposed to pull? Guess what? Everybody else probably has too, the same door. Like, if you look at an elevator and you look at the buttons, you can tell when people have made mistakes, because like if they have a button and a number next to it, you'll often see that the paint on the numbers is worn down, because users often press the number instead of the button. There's things like that you can observe and know that there's something wrong with the usability of your system, because when the user wanted to do something, when they wanted to use your system, they were not able to do it. They had no usability. So keeping an eye out for mistakes that people make helps you know how to make your system better and meet their needs. Okay, utility, an elevator, it gets you to where you need to go. Not all things have some specific task that they need to do. I have a highly usable fidget cube. It doesn't have a task really, so its utility is quite low, but it's very usable. I like clicking it. And then usefulness. Usefulness is a a combination of having both utility, it's accomplishing a task and it's usable. It's getting you, you to make fewer mistakes when you use it than when you use other stuff. So for example, I know a lot of people like Macintoshes because, not the Apples, but the computers, because when they use a Windows machine, they feel like they don't know what they're doing. They pop on a Mac and everything's intuitive, just snaps of them. You know, I never really experienced that, but I know that some people just snaps. I mean, this isn't an iPhone, but when we're talking about the iPhone, they revolutionized the industry because they found how to make a utility, which is your phone, have smart stuff in it while also being highly usable. Most of the things, BlackBerries and stuff to the point, weren't usable in 2010. They were only for the business class. So having usability makes your product more marketable, especially if it's feeding some sort of need, feeding some sort of utility. Games are sort of a utility because they provide entertainment, and entertainment is definitely a utility. You know, it's the biggest industry in the world. I'd say it's serving something. And I'll skip that stuff. Okay. There's kind of different metrics, like when you're deciding something's usable, and I'm saying, oh, you're measuring things, like, oh, I'm observing that those buttons weren't being hit, but the numbers were on the elevator, so and the paint's worn off. So and you can kind of apply them to different categories. So when you're looking at players play your game, you ask yourself, like in Pikmin, were they able to figure out that the red ones were able to withstand fire and the blue ones were able to go in the water? How easy is it for users to accomplish different goals in your game? Efficiency, do they get better at it as they understand your systems? Is there a learning curve? And then once they've hit that learning curve, they can do everything better than the person who's just started. If it's the same, then you're playing like checkers or war. Well, checkers at least have some skill. You're playing war, you know, the card game, where there's no skill and there's no learning curve. It's just, is the number higher. So is that fun? Arguably, when players have the ability to get better at your game, it's inherently more fun, you know, but depending on the audience, kids, young, like toddler kids have less need for getting the most efficient routes because they just like repetitious tasks. So depending on your audience for a game, I wouldn't say, oh, there's no learning curve, therefore bad game F. I'm not going to do that. But there is a place for having learning curves. I'm just reading it and then I'll translate it into something better. Oh, okay. So if they left for a while and they come back to your game, does it seem like they remember how your game works? Or was it not memorable enough? Did it not stick with them so that then they have to like figure out a bunch of odd rules? So like games that have more, I'm trying to think of a good example that from modern times, but games that just have a bunch of fidgety systems. I don't know if you've ever left a game and then come back and go like, wait, I have no idea how to play anymore. That happens to me often with like some of the more complex RPGs from like the early 2000s, where there's a bunch of crazy systems in them. Like all the ogre battle games, they have like they call it an alignment system, but you don't actually know what your alignment is. You only know your alignment by like interacting with other characters. So whenever I get back in the game, I'm like, wait, how do I know whether or not you capture cities in it? And when you capture a city, you either capture it or you liberate it. You want to liberate it. You don't want to capture it. So I never know. For the first like hour, I'll just be taking one city at a time until I figure out, oh, these ones I can liberate and these ones I can't. But then I have to like relearn it. There's like a really big ramp up every time I return to the game after a couple months. So how do you make sure that your game has memorable features? One typical thing, like in Pikmin, oh, red is fire, blue is water. Like just having really clear visuals that communicate obvious things. How many mistakes do they make while they're interacting with your system? I'm sure that you've played a game where you make the same dumb mistake over and over and over again. It's very typical, especially for like the Dark Soulsies and the I'm trying to think of like another typical game where I see a lot of mistakes really often. Like oh, I saw somebody let in the room. Hey Sarah. Hey Sarah, how long have I missed your entry into the room? Was that relatively new?
It was just new, yeah.
Okay, cool. And by the way, I thought that I said, "Hey Siri," apparently. So we were just talking about usability in games, and usability is just a way that you can measure how easily people interact with your product, your game in this case. And I was mentioning that usability is usually something that you can measure. So for example, when you go into an elevator and you see all the numbers, the paint on the numbers is worn down and the buttons are next to the numbers, and you know a lot of people press the number with the paint on it instead of the button. And that's an example of knowing that you have bad usability. There were a few categories of usability that help you figure out when you're doing play testing of your game, like, oh, where is the person messing up? Is it that they're not able to learn the system? So there's some type of learning curve that prevents them from accomplishing a task, like, you know, jumping over the first hurdle. Is there not much of, are they not having fun because there's no learning curve at all? Like they're playing war instead of playing poker. War is inherently, there's no skill involved. You just put the cards out. So there's no like more efficient route that having an understanding of the system can get you to. You're just putting down the card and seeing if you win. So the less random your system is and the more learnable your system is, then the higher skill cap there is. And that means that they'll find your system more usable and more fun. When they come back to your game after a while, are they able to remember how the game works? If so, that means you've probably made a system that would be considered memorable and that they would probably like to come back to. If they don't remember anything about your game after they've played it, there's a problem. Like if they have to relearn the rules every time they return to it, which is like me and Catan. Every time I come back to, I'm like, I know it's an easy game, but I've forgotten everything about how it works, except for sheep. I always know that I want the sheep cards. Errors. How many errors do they make when they're trying to accomplish a goal in your game? Are they doing the same mistake over and over again? Are they, like in a lot of games, I always hit the wrong button to open the wrong menu at start, and then I have to close and then go to the other one. Like an inventory screen versus a crafting screen. I'll almost always just hit the inventory screen because to me, crafting is a part of your inventory. So it's just the way I think. So I make that error quite often. Errors are often expressed in two ways. Either they've done what I did, a slip, where, oh, I wanted to do one thing, but I accidentally did something else. And then there's mistakes where you completely misinterpreted how to accomplish your goal in the first place, and so you do it wrong. Like, oh, like I'm sure you've seen people play like a Mario type of game where they just run off a cliff over and over again or get hit by the same guy over and over again, not because they made a slip and thought they were supposed to. They just don't understand the system in a way that helps them get around the particular hurdle that they're hitting. And all these things feed into their eventual satisfaction of the design. Like, do they actually like what they're playing? These are all parts of what you would consider usability, because things that have higher satisfaction are more usable. They want to use it more. Things that have lower satisfaction, even though they do everything else perfectly, are going to be less successful. You know, like the Microsoft Zune to the iPhone, like people just found more satisfaction in using the Apple product than they did in using the Microsoft Zune. As much as I am an advocate for the Microsoft Zune. So one good example of approaching usability in different ways in games is, I'm sure you've played a game where you have to use a keyboard and you have to like actually use like a QWERTY keyboard, like that's set up like a normal keyboard, but you have to use your analog stick to like go to it, each letter, and it's really annoying, because that's like what every game does. There was a game called Beyond Good and Evil, which actually just got re-released like a year or two ago, I think. But Beyond Good and Evil, classic French designers, they noticed that, you know, you're using your analog stick to select letters, so they actually mapped all the letters across like a rotary scale. I mean, they've been making a sequel to it for 20 years. Devin, it's a thing. It's been a joke for a long time. We'll see if they. I mean, they confirmed it 4 years ago now. We'll see. I'll believe it when I see it. The first game was great, and then the second game has nothing to do with the first game. It's like a weird MMO. Okay, anyway, I hope it's good. You know, I'm not trying to put it down. I'll wait till I see it. So they made a rotary selection method so that you actually just spin your analog stick, and it was much more accurate than having to like click right 40 times to get over the right and then hit down a couple times and then select. Now they can just spin their wheel until they get there. So that is usability. Now we're going to transition. I might even add some, I'll say feedback here, and then I'll say usability down here. Well, just to split stuff up a bit better, and then I'll re-upload it. And then I'll say affordances here. I'll try to go pretty fast. Okay, so affordances were introduced by that other book I mentioned, The Design of Everyday Things. I do recommend that book. It's actually pretty funny. The book itself contains an art series about like it was like an art show where a guy just made a bunch of tea kettles that pour on themselves as an example of like bad design, essentially. This is just a little statement, just funny. But you just see a bunch of different like weird teapot concepts where you're pouring hot water on yourself. Anyway, what was an affordance? An affordance is using the visuals of something inherently to explain what you should do with it. So I'm sure that you've seen all these things in computer terms. Like, what does a scissors mean to you? It means that you're cutting and pasting content. What does a folder mean? Well, it means you're containing some information about it. And is this still relevant? So do you guys still see floppy disks in your icons? I think that Word, yeah, you still see them, right? Word, probably,
Yes.
yeah. I mean, even Home. I just want to verify. Do they still use it? Oh, you know, I don't see it at the moment. But you guys know it's to save. Oh, you saw one up there? Am I crazy? Or is it up here?
Yeah, it's up there. Or we're looking for somewhere else.
Oh, I'm looking for anywhere where there's a floppy disk.
I think it's my next.
Right
Oh, there it
behind
is.
autosave.
There it is. Yeah, so like a floppy disk hasn't been relevant since 1988, but it's persisted as an icon for saving. So now it can't change, because when you look at a floppy disk, you now think save. Before, the affordance was they see a disk and they know they can remove it and they can put it different places. When they see that disk on a computer, they know, oh, that means I'm putting data on a disk. That is an affordance. A scissors, a good example of scissors in software is, you know, cutting and pasting, but in the world, that's a bad art of scissors. In the world, the affordance in how to use an actual pair of scissors is built into the design itself. You inherently know the first time you pick it up that your thumb goes in the one side and your fingers go in the other, because it's physically designed to invite that type of grip. So how can you design your products to imply the proper use? Well, you can use design to constrain behavior. So it's actually adding constraints to how your product can be used so that it's used the correct way. You'll see this a lot in safety. So like when you plug in an outlet, you know, one side is big and one side is small, because doing it the other way is technically a fire hazard. So they physically design the system to prevent you from doing it. And you generally, unless it's a USB, you generally know which way to plug it in first. Okay, so the official definition is using a visual representation to imply function. So it helps guide the user for using your product if you've made your interfaces and your game in such a way where it's clear what you should do. So do you guys know Perfection, the board game? Not whatever I just went to.
I'll say I'm looking more at that fish guy. What was that?
Yeah. So like Perfection is like the perfect example of an affordance. I need to put all the pieces together, and each peg is a very specific shape. So I know that which piece should go in. There are other matching games where you only kind of know that things are wrong in the end. Whereas this one, you know right away. Oh, that one fit, that one's right. This one didn't fit, this one didn't work. So Perfection as a board game has a solid representation. Man, am I that old that people are like, wait, what is this game? I remember Perfection from my childhood. Oh yeah, the timer stresses you out. I did a little animation. I wonder if it's still around. That's probably not. I did a little animation Perfection once with like a little character trying to find his slot, and he kept doing it wrong. Anyway, so when I talk about an affordance, that's what I mean. Is like, did you make your system in a way where when a person looks at it, they know immediately what to do? I'm seeing if I want to talk about, oh look, I've talked about Perfection. So like I said, constraints are things that you've put into the system itself that tell the user how to interact with your product. So they know to put the square thing in the square hole. In games, constraints are often in form of fading and revealing things. So even though you have a big complex menu, when you're interacting with, let me see if I can make it bigger. When you're interacting with things in like not Left 4 Dead, in Last of Us, they actually fade out sections of the inventory that you can't currently do. So the user doesn't think that they can. I don't know if you've ever used interfaces where they don't like give you a good eye focus for when you're interacting with it. So like you're trying to get to a certain menu option, but you actually can't select it right now, and you have to like select something else somewhere else first, like a pop-up, but like it's not letting you interact with the other thing. Having fade outs is one way where you can prevent users from trying to do certain things when they're not supposed to at the moment. Like, oh, you just crafted a smoke bomb, you've got to wait, or you can't do these particular actions with it, or in this particular case, it's a crafting screen where you know, oh, I need these two things. I don't need the other items. So in addition to constraints, you can also do mapping, which is the layout of the scene, of the game, or of the interface itself implies function. A really good example of it in the real world are stovetops. I don't know if you guys in college use a lot of stovetops. I'm sure you do. My dorm did not have a stove. We had to microwave everything. But stovetops are a great example of mapping affordances because every stove you come to is different. And you have to measure when you create a particular stovetop design, how often I want to do the left stove. Oh, somebody's popping in. I want to activate the left stovetop, bottom left. Which of the knobs do I turn? So which one has the highest efficacy of a user not making a mistake when they turn that knob? This one has a 100% efficacy. They never make a mistake when the mapping is helping the user make a model of how the system should work by laying out items in a way that's intuitive for the actions available. So for this one, it may be a bit unclear. To me, it's clear, oh, these two should do the two center ones. But when they did study on it, about 60% of people made mistakes. Whereas this one, because it's so one-to-one matched on the sides, they never made a mistake. And this one also has what you would call mapping, because this has four items arranged in the same way that these 4 ones do. Though it looks like people still made mistakes, most likely because these two are closest to these stoves. In my house, because Mr. Irvy, the guy who lived in my house before me, decided to do all the electric himself, he made every light do exactly the opposite of what you would think it would do. Like the light that's closest to me turns on the light that's farthest away. And then the light that's farther from me turns on the one that's next to me. The entire wiring in my entire house is like that. And I make a mistake literally every time. And I've lived here for a year and a half. So it drives me nuts, but there's no way you can fix it because there's, you know, studs and drywall. I'd have to go up in the attic and like rewire the whole dang house to fix it. So it's definitely a problem that people don't exactly consider sometimes, and they're making products, and it happens to us when we're making video games as well. So in games like Zelda and others I'm sure you've seen, they have the buttons tied into your interface usage. So they map by showing you, okay, green button, and I look at my controller and there's a green button on it, I know exactly what that one should be. Blue button, okay, that's my A button, I know exactly what that should do. 3 orange buttons arranged in a downward triangle. I don't know if you guys know the Nintendo 64 controllers, so I'll just show it. As you know, I think that was like 6 years before. You guys are like 2000-ish birthday, right? So
Yeah.
the Nintendo 64 is only relevant until like 2001. So, you know, I doubt you're playing games at 1 year old, but maybe you played it later. But an N64 controller had 4 yellowish, orangish buttons. So you would know just by looking at this setup, oh, that's what I'm supposed to do. It's harder for touchscreen games, 99 game. It's harder for touchscreen games because you have to not take up a lot of the screen because it's that's your play space and your visual space. And you also have to communicate what will happen when you press a button. So that's why they usually do like virtual versions of these buttons where you've seen like directional buttons that are in the bottom left and like little interaction people in the bottom right. Old people, yeah, I take it. I'm old. I'm distinguished. But yeah, so that's just a quick primer on like affordances and usability and what's the first one? Feedback, right? Yeah, feedback. So when I talk about user interface stuff, when I talk about I'm interacting with your game and it doesn't have affordances that tell me how to do certain things, this is exactly what I'm talking about. Like, how do I know that the red Pikmin can do fire and the blue Pikmin can do water? How do I know that, you know, I don't know. I can't do, I was gonna say like, how do I know in Genshin Impact that's something, but I've literally never played Genshin Impact, so I'd be talking out my butt. Is there fishing in this game?
No, but you can like pull fish from the water for like supplies and stuff.
Okay, I'm like,
You can like hunt in the game.
dock. So I was gonna
so-
say like, oh, how do I know where I can fish and where I can't?
Yeah.
Though in Animal Crossing, how do you know where you should fish? Is because they provide you a little shadow of the fish in the water, so you're not just guessing where you can fish. Though in Genshin Impact, I have zero context, but I know it's very popular right now. I still need to get around to playing it. So with that said, let's start talking about game design documents and how they're kind of constructed and what my expectations are for the homework this week, because it's kind of leading into a game design document. I'm not saying make a game design document in 1 week. So this is from that book I referenced before. Feel free to page through it in certain sections. I think I like page 337 or something is where I'm starting from. A design document provides all the details for creating the game and how help young sport. Oh, what's up? Did I get to that message really late, Mercy?
No, when I think something's funny, I just type help in all caps.
Oh. I didn't follow that meme, but now I know.
Okay.
So a game design document lays out everything about your game, from the name of it to how it's played, to showing examples of level designs, to showing art assets that you're planning, concept art, so to go like, oh, this is what we're shooting for. It covers everything about how you intend to accomplish your game. And as you create your game, you update the document over time to make sure that they're still matching what you're actually doing. Like if you realize something is bad while you're making it because you've play tested it, then you don't just leave the document in place and just keep chugging along. You go back and you change things, and you're allowed to update the document as you go. So in general, a game design document has an overview or vision statement where you say, this is what I want to make, and these are some important aspects of it or things that make it unique. You have a section about who you think is going to play your game and where they're going to play your game. So for example, ages 10 to 12, because it's an action adventure game that doesn't have a lot of competition in it. So it's not like marketing to like the 18 to 30 audience. It's more about adventure, and it's on the phone. So like kids like playing on their phones. The kids these days, so everybody honestly plays on their phones these days. What kind of gameplay you expect. So marketing also includes, by the way, like how much you think it's going to sell and stuff, but don't do that for me. Like that's usually more for like a person who would be signing off on funding your game for a pitch. Gameplay are all the mechanics and dynamics in your game. So mechanics are like specific features that your game will have for how a player can move and interact with the world. A system is using those interconnected mechanics. Does it create something new? So economy is a good example of the system, because you have money and you have things that earn money, the things that you use your money on, and how that changes the game in-game currency, not like physical money. The way that what your economy does to change the game and make it more fun or more difficult, whatever it is you want to do, is a system. So are any of y'all familiar with Hades? The game that came out recently? Okay, cool. Yeah, y'all know Hades. So in Hades, you start out with a core mechanic package of you can move around, you can dash, you can slice people up, like demons up. And as you play the game, there's an economy of getting new abilities that stay with you every time you die. So you purchase these abilities, or you earn those abilities, and the system comes into play where every time you play the game, you get exponentially stronger the next time you play. How did I do that face? Which face? Oh, did somebody do an emoji that I missed? Oh. This one? Anyway, we're all wizards. So how does your gameplay have systems and mechanics, and how do they work together, and what's the intent, all that kind of stuff that we talk about. I'm a Nintendo person, so I'm less interested in these optional sections, like, oh, what's the world you're building, what's the story you're building, what's the characters in it. You can talk about those things. They're optional for me because I'm more looking at the gameplay that you're making. That's just my personal approach. But if these things are important to you, like if you're trying to create a world, then of course include it and stress it. You know, I'm not going to stop you from making the game you want to make. They're also optional in general because they add, 200 pages to a game design document. If you're going into the deep lore of your system. But it is important to a game like Cyberpunk. Like Cyberpunk is all about its lore and its story. Games that are gameplay second to the story, like Skyrim and Cyberpunk and Witcher even. Witcher has a ridiculously deep storyline. Those are all things that these categories would benefit from. And then a media list, which is at the end. You have a lot of concept art and all that type of stuff. You throw it down there, and maybe you have some text blurbs describing it. So that is kind of an overview of a game design document. I think I go through and I have little definitions for each thing. You are free to review them. The only one I want to stress at the moment are the overview and gameplay sections, because that's kind of going to be a part of your homework this week. Because there are some things about gameplay that I didn't mention when I was talking about, you're describing how games and systems interact. So when you're talking about a vision statement, you're talking about things like, what is a one-sentence description of your game? How can you simply describe your game? Because if you can't, then people trying to understand your game won't be able to get it either. And how do you expect the game to play? What do you expect them to feel while they're playing it? Like, oh, it's an action-packed 2D shooter where players compete to collect the most, and you're using a lot of those keywords so people know, so they know what they expect when they're playing. I think one person in here was talking about a collectathon. That's why I use that term. And saying 2D shooter gives you scope of okay, that's what the game is. Okay, is it level based or is it open world? All that type of stuff would kind of be thrown out here. I talked a little bit about audience and marketing. I won't focus on it for now because that's going to be for a later date. Gameplay. Not only do you talk about the mechanics and the flow and how they influence systems of your game to make it more complicated, but you also can talk, and it doesn't have to be that complicated, by the way. It's just an example of having systems that feed into each other, because that creates engagement. That's just a way you can create engagement, of having your mechanics all kind of work together in some way. But it also includes wireframes, which you've done a little bit of, and flowcharts, which you haven't done yet. So wireframes are sort of like those prototypes that you made, where it's just simple screens that show what interaction will be like at certain locations in your game. So in the inventory screen, this is what it looks like. In the play screen, this is what it looks like. At the start screen, this is what it looks like. When you're doing wireframes, it's highly simplified, like squares, just showing where things are going to go. A low fidelity prototype, then in those squares, add some kind of concept-y art type of things. And then as you go up in the prototype levels, you then make those kind of sketches look better. And then a full-on mock-up means this is what I want the final product to look like, where you really go balls to the wall to make the art look really good. A flowchart, on the other hand, connects all those wireframes together. So how do you get from this one to that one? Well, you got to go through a series of steps. The player hits the start button. They select a new game. They type in their name. They confirm. They do all these things. So all those are parts of a flow that you create a chart for, so that as an artist, you then know, oh, I need a screen for here, here, and here. Oh, yeah, I copy and paste mine too, by the way, for that emoji. So a flow chart, you'll notice that this is for, I think it's for Jeopardy. Yeah, it's for Jeopardy, or Wheel of Fortune. So they actually have a number next to each of these because then they have a corresponding mock-up or wireframe, depending on the state of the game's development. They'll have a mock-up for each thing, and they numbered it in order of when they appear. So a flowchart just shows you from the start, how do you get to particular screens? How do you get to particular parts of the game? When do you see the credits? When do you see all those types of things? So it helps you think about things. And then for each one of those, this is kind of the mid between I would say the top right one looks kind of like a mock-up or a wireframe because there's not too much art in it. But then as you get toward this bottom one, I'd personally call that closer to a low fidelity prototype or something because there's a lot more care put into like, oh, there's like a visual style, seems very cartoony, whereas this one is highly simplified. That's just how I would put it. But here you'll notice that if it's even visible on your screens, I don't know the resolution. Here they have a much more sketchy style, so this is kind of lower fidelity than this one. It's a range, but for each one of these flowchart elements, they'll have a corresponding wireframe or mock-up of some sort to show what they're going for. Honestly, I'd say this is really close to a mock-up, except it's not colored, which might just be because this is from a black and white book. I myself have made many flowcharts in the past for the games I work on. For example, when I was working on an eye tracking game for kids with autism, where it was about talking to characters and you had to look at them in the eye when you're talking to them. We needed to have a process whenever they started the game to make sure that the eye tracking was still working. So they'd have to look at a few corners and then they could continue with the game. So they'd come back from some mini game, like we had an asteroid shooting game. My turquoisey color means that there's a flowchart somewhere else because the flowchart ended up being like a poster size of flowcharts. So I cut them up. So they come in from some other flowchart, in this case, asteroids, an asteroids minigame. And then I begin the eye verification process. They get a prompt that tells them what to do. It says press X to display. I wait for 10 seconds. And during the calibration phase, where I'm waiting during those 10 seconds, are they looking at the corner that I want them to look at? There's like a little circle that pops up. If they did it correctly, then I show, then I continue to the next phase. If they didn't pass it, then I check to see if they have any time left to look at the target. If not, then if 10 seconds have passed and they failed 3 times, that means that I should tell them to try again. If they did not try again, then there's some error going on, and I show an error prompt, and I tell the teacher who's administering the game to do something, because it was kind of a paired game where there's a teacher and there's a interactive game, and there's the eye tracker, and there's the kid. So there's kind of different things working together, and I have to send messages to different people. As I said, the media list is just a list of all attached files. Oh man, what was my time today? 9:41. That's pretty good. Like an hour. So that's actually what I want. So, okay, cool. So that is a game design document from a super high level. And before that, those were cases in usability, affordances, and feedback that I think are important when you're making games. With that said, we can kind of move on into what the assignment's going to be this week. And the labs. So the lab this week, I have a little introduction of it, but the lab this week is a little, come on. It's gonna be that option screen you made last week, but now you don't need to do it in the same scene I just did because it's gonna tie into future lessons. I have a little player in it. When I tap the screen, he jumps. When I press left and right, he moves left and right. I'm going to create an optional second half of this lab that you do not need to do, because I've been noticing that I've had two sections of each lab where like I have two separate recordings, and the first recording generally takes people up to, you know, a day before the end. And I realize that that's probably stressful, and that maybe I'm giving more than a week's worth of content to work on in a week. Like, I don't want to be taking, would you guys say that the first half of each lab takes you more than, say, an hour to 2 hours? Would you say that it takes more than 2 hours? Let's say that. I'll look for emojis in the chat.
Yeah.
Yes. Okay, so
Yes.
given that labs are supposed to be really a part of my lecture, a class is only like 2 to 3 hours long. And I've already taken up, you know, an hour and a half, 2 hours of talking. So I would expect this lab to be, and then the second half of the lab, does that take another 2 hours? Okay, cool. Just one for you? Okay. So I'm trying to find a good balance, because I don't want to be taking up your entire lives on the labs, because the labs at the end of the day are only worth 2 or 3 points for each one. I'm just trying to show some fundamentals of development through them, with the hopes that you can carry them over into the homeworks when we start doing the group projects. Okay, cool. Once the first hurdle is passed, the second hurdle is good. So I'm going to do an optional second half this week, where not only do I have this little jumpy cube jumping around. Did I mess something up? Where did did anyone see how I got rid of my options button? It was weird. I have a bug somewhere. Oh yeah, there's the bug. Okay, cool. Now I know. So the my jumpy cube, you may work on this in the group. The jumpy cube takes up a few things. You're going to make a player movement controller that reads the inputs and tells the animator on the character to do a little jump. And you're also going to have a reference to the transform of the character, so you can move them left and right. So an animation makes them jump upwards. But it's really reading the rotations of a screen. And then I created a backup control for key inputs like mouse and left and right. And I do that right in the lab, so that if you can't get it working on your phone, like using the Unity remote thing, if you just wait for the end of the lab, then there are also ways of making it work on Windows or Mac, doesn't really matter. So there's both a little movement controller that tells the character when to move and how to move, and there's an animator. Are y'all familiar? You spent literally the whole week working on part 1. Oh, yep. And I realized that I'm trying to course correct the way that we're designing these assignments, because you know, everybody's different, and I don't want to sacrifice your other classes for my class. You know what I mean? Because I'm sure that everybody has more important things in life than following a 50-minute lecture of me recorded. Do y'all have experience with Unity's animator? Some? Okay. Okay, you don't remember much? A little? It's been a long time? Little? Okay, good. This is going to be fun. Okay, so basically, in Unity, animation follows a flow. So from entry, I wanted to do idle right away. So you right click, make a transition and do there. Unless they're already, the orange means that it's default. So right when you drag in the first, if I go to my project, I drag it in here. I drag in idle. You know, that's just how you add them in. Boom, boom. I've right clicked create an asset, and I made 2 animations, and I made 1 animation controller. The animation controller is this grid here. And then the 2 animations were idle and jump. I connected the 2 with arrows by doing right-click, make transition. And then to make jump only happen when I want it to, I created a parameter, which is over here. There's a parameter. I hit the plus button, and I made a trigger, because a trigger, when it's true, it's only true for a frame. Boom, do it. And then it goes back to false. So this transition says in the condition section, notice that not all of them have conditions. In the condition section, I added the condition that it needs to be jump triggered. So when jump is triggered, it will switch from idle to jump. And then when jump animation finishes, since I don't have any conditions, it just waits for the finish, which is what this is, the exit time and the blend time here. Then it knows to go back to idle and stay there until jump is true again. That's all the animator is, nothing too crazy. And the script touch controller, relatively short, I think under 50 lines. Let's find out if I'm honest. Am I honest? Dang, I'm dishonest. It's 64 lines. I'm so dishonest right now. But you don't actually do this. So it's only 56 lines. Ignore this do jump. That was the first way I was going to do it. And then I was like, wait, I'm doing this a programmer way. I should do this, an animator artist way. So ignore that IE numerator if you see it in my other scripts, because I don't think I ever even talk about it. Okay, so there's just an update loop where you listen for horizontal movement, which is moving left and right, based on either the input.getAxis horizontal is left and right keys on your keyboard, and input.acceleration are tilting left and right on your phone. So I basically have 2 options where I first look for the phone. If I don't see a phone, so if I listen for the phone, then I listen for the keyboard. If the keyboard is receiving input, then I use it. I just assume, okay, I should use it over the phone. And then I apply that motion to the player, which I talk about more in the lab. I'm not going to go too far into it, but basically, if I see that the horizontal movement should be 1 or -1, depending on the direction, then I move the player in that direction using similar logic to what happened in the rolling a ball lab that you did a couple weeks ago. Okay. And then this should jump. So every update loop, I do horizontal movement, and then I wait to know if I should jump or not, then tell the player to jump. Should jump is just a method. And when it says bool should jump, that means that it's going to return a true false. A boolean is just true false. So should jump returns if touches, which is how many fingers are on the screen, if I have any touches on the screen, and if that particular touch is currently in the began phase. So if I were to type dot, every touch that occurs on a screen can go between the player just began their touch, they're moving their finger around, they're staying still, they just ended their touch. I don't know what a cancel would be. That seems like some system thing that would cancel a touch. Maybe if you're touching and then you do another finger. But began, ended, moved, and stationary are exactly what they sound like. I don't know the exact definition of canceled. So when I just put down my first finger, so that means my finger number 0 is in the begin phase, then I return true. Otherwise, I return false, unless I'm using my mouse to do a fallback for if I'm not on my phone. So that way I can tap my mouse and everything's fine. And that's basically it. I play the animation. I guess I'll mention, like, if I go to my animation here. Come on. If I go to my animation, which I dragged in. So let's find it. There it is. It's just a series of keyframes, just like in Maya or whatever. To preview that on your character, you got to make sure, I put it on the cube root. Your cube root has a little animator controller here, which I drag this animator controller into, boop. And then if I'm selected on this that has the animator on it, then it knows to move this character when I drag this left and right. If I just went to the jump directly, it doesn't know who to apply this to. It has to have context. That's why you click on the player cube root first, and then it knows. So this is my idle animation. I can hit down here and go to the jump animation. Scoop. There's a little jumpy cube. To add a keyframe, you can right click and hit add key. So you move it to wherever you want. I recommend, for me, the way I did the jump animation was I didn't animate the cube root directly. I animated the cube within it so that I can start off at 0, 0 and end at like 0, whatever, 1.6. I don't like animating the thing with the animator on it because then other math and other movement gets weird, because if I'm trying to move them left and right by tilting and I'm trying to move them with animation, they might conflict with each other, and I don't want that to happen. So that's why for the jumping, I animate just the cube within the root, and then for movement, like moving them left and right, I move the root itself so that he can kind of manage both things. So that's the lab this week. There's a video accompanying it, and yeah, have fun. You know, don't make my jump directly if you don't want. Have fun with it. Make it cute, especially since it's a group lab. You know, somebody can go nuts and like make a crazy little animation. I invite it. It'll be cute. And you can make different idle animations. You can make whatever animations you want. Maybe he doesn't jump. Maybe he ducks. I don't know. Whatever you want. It could be a sphere. I'll even let you make a sphere instead of a cube. But me, I just made a little jumpy cube. I'm curious how I broke this. I see an error down here. That's probably why. Anyway. Okay. So that is the lab this week. And the assignment is going to be starting to plan your final project. I'm even going to bold this. So this is your final project, which is going to be a game of some sort. It could be a game you've already worked on previously. It could even be Jumpy Cube. But I want you to draft a vision statement, have a gameplay overview where you talk about how you expect the game to play, like what kind of mechanics will the player use, all that type of stuff, and create a game flow diagram. I also want, boom, low fidelity prototypes, just like what you did with week 1. So nothing more crazy than that. I know some of you went really crazy, but given that there's a lot this week, I want to have a game flow diagram that shows how they're going to progress from one screen to another. So just like up here, or like the one that I made, this one, you know, it's all good. You could sketch it out if you want, as opposed to using like like I used Google Draw. I just prefer that system because I work with it well. New Google Drawings, and then I can like just go in and make a cube. Boom. Oh, auto fit text, that's nice. Boop, boop, boop. And then you can kind of connect them just by doing a little arrow, boom. And so that's how I do it. But everybody does different things a different way. Wait, so we use the paper prototype concepts for this too. Oh, are you talking about the ones that you did for homework 1? The answer is, if that is the design you're going with for your final project, then yes, you may continue to use those. And then also make sure that you, for each one of these flowchart parts, where it makes sense. So user loses, or user, or like gameplay. I don't know, there's gameplay phase and moves across screen, and then dies, and then game over, and then try again. You know, it's probably not going to be worded like that because I kind of worded it poorly. Oh, look, a doc version of the paper prototype. Oh, did I answer your question? Okay. So, oh, I did. Cool. Cool. So I would expect to see a screen probably for this one, that one, this one, and then dies kind of happens and connects you between moves across the screen and game over. So make a flow chart, and that helps you identify which prototype concepts you need to make, like little paper prototypes. Some people might already have all the stuff they need. Some people, because I only said, oh, make 2 or 3 screens. Some people might need to make more screens if they're using their original homework assignment as their group project. I'm not going to tell you what to do. You can make your own new project, or you can use a group project because for every group, there's like 2 to 3 people, meaning that there were like 3 original concepts made a couple weeks ago. I'm not going to tell you not to use them. So that is my expectation. I want to see a quick, less than a page pitch statement. Hey, this is the game I want to make. These are some aspects to it. This is how the game is going to be played. That's kind of your written part. So vision statement and gameplay overview, which I talk about and I provide examples for in the assignment itself. I'll navigate there just to walk through it. Then also create a game flow diagram that shows how all of your gameplay connects, which I also provide some examples of. And then after you've made that game flow diagram, make sure that you have low fidelity prototypes, quick sketches, or, as detailed as you want to be, of each screen that is identified by this flow diagram. The flow diagram is how you plan, how you know what you need to do. So boom, that's your homework this week. I'll pop over to the assignment itself. And it's here. Boop. In this document, I provide a few things. One, I give the specifics to what I expect to see in the vision statement. I could also provide some additional concepts for what I expect to see in the gameplay description. But I trust that you guys can just say, this is what I expect the player to do. And again, I'm not going to be too super specific about it. There is technically a way to talk about gameplay that I think I'll maybe teach later so that you don't have to get too in the weeds in this one. But I do provide specifically what a vision statement is. I provide the chapter of the book here, chapter 14, where it talks about flowcharts, and I think there's also a section on, oh yeah, the formats for your documents, which we'll start with vision statement here. Don't worry about design history. All that's saying is it's like keeping dates of when you've modified your document. I'm not going to stress that. Your vision statement, it provides a little quick overview of what that is. And gameplay, it has, when I say, oh, talk about your gameplay, you might want to look at this. So what are the interfaces, the rules, the scoring and winning conditions, what kind of modes and features? Is it going to have multiplayer? Is it single player? Is it level selection? Is it open world? Provide your flowcharts, and no, don't talk about edit. You're not making a custom level editor. You're using Unity. So yeah, there's some explanation for what gameplay is in this document as well. And like I said, I provided a little screenshot so you know, oh, that's what he means by providing a flowchart. And Oh, that's what he means when he says provide some low fidelity prototypes. I used one of yours because I really liked it and it's cute. This is Angel's, right? It's really good. I love it. No problem. It's really cute. But you know, I saw a lot of great stuff over the low fidelity prototypes, and I think I voiced a lot of it. Like even the weird stuff. Like who did Pepsi Man? Somebody did Pepsi Man. Oh, Belinda. Yeah, Belinda did Pepsi Man. It was really good. So, you know, I'll take it. You know, there's so many right answer. There's so many answers to a question that doesn't have any right answers. Like you can make it look however you want as long as it achieves your goals. Like as long as it communicates to you that, you know, this is what you want to make. But here's an example of a good low fidelity prototype. I'm not looking for much more detail than this, just enough to communicate to me, okay, what do I do with this screen? So yeah, I hope this makes the homework more clear and less confusion. Oh, are you actually you're using that? That's funny. Let's go to Drive. We're pretty early. We're chill. I just wanted to go over the survey for week 3. Boom. Because I just wanted to look over and make notes of a few things. I'm glad that I respect your time. I'm a little worried that so many of you feel this challenged by the class, so I want to bring that down a bit. You know, 5s and 6s is what I want. I don't really want 6. If you want to fill out the survey, you can, Sarah. Here. It's anonymous-ish because it just combines everybody's answers in the end. I'm glad that many of you feel like you're learning meaningful things about game design, mobile game design. And I understand the person who doesn't feel that way because it's kind of difficult when it's all remote for me to really dive into getting everyone to be able to build on mobile and really accomplish something. But I'm hoping that toward the end of the class, that I can at least get us up to 4. It's like, okay, everybody knows the general flow and they've made enough in mobile type environments that we can do something. Glad you feel I respect your time. Did I ask that twice? Oh no, I think I just scrolled up. I'm glad that all of you feel like you're putting a lot of effort in the class. You know, I can tell it's looking good. And yeah, Illustrator, you know, I'm at a 3. I'm at a 3 myself. So I hope that these tutorials that I'm providing you get you. I'm probably at a 4. I don't know. I don't have a high self-esteem. I'm probably at a 4 because like I don't use it that often because I'm not really an artist by trade. I'm kind of a technical artist. I go in and I make shaders. I do that kind of thing. But I am glad that my tutorials might be pushing you toward the farther direction. And I'm hoping that I can get everybody out of the 2s and 3s. My goal is just comfortable, you know, just a 4, just a middle, you know, okay, everybody kind of gets a feel for it. That's fine. Unless, of course, you like using a different program, then I hope that you use that different program to the best of your ability. Comfortable using Unity, I'm looking for 4s. So I want, oh, because somebody responded. Okay, I want to get to 4. So I'm hoping to push everybody at least up 1 unit. Because Unity is this class, it seems like. I'm happy to teach Unreal if anybody wants. Or if anybody's taking other classes where they're being forced to use Unreal, I have like 7 years of experience in it. You're allowed to ask me questions. Oh, sick. I'm glad, Mercy. Hey, what's this one person here? When have I not been there for you? No, I'm hoping to be a 4 here too. Like, I've been there a lot the past 2 weeks, and I feel like I should probably tone it down a bit. I feel like I'm a little too hands-on, but we'll see. If this is working, I'll keep doing it. Because I know that I'm getting used to you guys, and you guys are getting used to me.
I just worry that like you feel like you need to respond like right away, and you don't have to. If you're like, it's 1 a.m. and you're like, hey, what the fuck? Why are you messaging? You don't have to respond.
Oh, I mean it purely as a joke. It's purely
Okay, okay, but yeah, like
because I'm usually working too. I work 4 jobs, so
yeah,
like I'm kind of poking around, and this is Discord, so I just see it on my left-hand monitor. I'm like, oh, what are you guys doing? Go to bed. Because like,
yeah,
oh yeah, don't worry about it. I'm usually up until 1 a.m. 1 a.m. is usually when I'll do a cutoff. Maybe I'll just say, okay, I'm not going to respond. So everybody knows, I'll probably stop responding to messages after midnight, and I'll respond to them at 8 a.m. But I know that a lot of you are working on these projects at 12:30 and want to turn them in now. So like, I don't want to have you stressing out the rest of the night when it's like something where it's like, oh, you just got to zip it differently and then you're fine. Like, oh, just delete the library folder. I don't want you to be thinking that I'm going to like hurt your grade because like a library folder. I just don't want you to feel that way.
I just didn't want you to feel like you had to be obligated to respond at any given moment, because a lot of professors are not like that.
I mean,
at
a lot
all.
of professors wait a week.
Yeah, exactly.
So-
You're always like instant, but I just don't want you to feel like that. You
Yeah,
have
it's no problem.
but like stressing you. Yeah.
It's no problem. I'm really more worried about y'all. Like, I think y'all shouldn't be working at midnight, 1 a.m., 2 a.m. To me, that's
That's when I work best. I can't lie.
yeah. So if it works for your schedule, great. It's just a personal
Yeah.
thing. And I like making fun of people for being up at 2 a.m.
Yeah.
Meanwhile, Justin's up at 2 a.m. Okay, I'm just briefing through this. Okay. Okay, so the live stuff is good. The videos are good. I'm glad that people don't feel doomed. That's my goal. Okay. I'm getting a phone call. Is that important? Ooh, I don't know the number. Not important. It's probably my car dealership trying to get more money from me.
Might be your car insurance running out. You know how
Yeah.
it be.
My 14-year-old car, God forbid something happens to it. Okay, cool. Well, I'm glad that this seems like it's working. And now let's look at the parts that aren't working. Yep, I heard that loud and clear. Multiple people asked for that, so I've done it. It is on YouTube. Okay, not midnight deadlines. I mean, to me, it just means, oh, just make sure that you're done a day early so you're not up till midnight. But I get what you mean. What due date makes sense for you? Is it just before class, like 8 a.m. before class?
Yeah, I think that works.
Okay, I'll do that. That's fine. I don't care. I'm not looking at it until now anyway. Okay, right before class. It'll be due right before class. Done.
Yay.
Okay. I suggest thinking more highly of yourself, whoever that was. Like don't say like, oh, there's a problem with me. No, it's all good. It's my job to teach you. Okay, so there's a bit of an overlap between labs and homework. I think this week it's more separate. It's more clear.
Yeah, I think so too, definitely. So yeah. I was the one that wrote that. So yeah.
Okay.
Yeah. I was just a little confused this week, but yeah, this week's a lot more clear. So
cool.
Yes, thank you.
And it's because they do have overlap, because I want like the work that you do in lab to like
To be
help
able
you.
to be used in the prototype.
So I'm like, oh, there should be overlap, but maybe I was like making it too much. Because my problem last time I taught a class was I didn't have them touch Unity until 2/3 through the course.
Oh gosh,
So
yeah.
I was like, oh God, they're artists. I didn't realize that. I thought that they were all like, I thought by year 3, this was at a different school in California. I thought by year 3, they all would have like been experts at Unity and like been really comfortable in it. Wrong. So just starting early, getting everybody to just touching the programs early is what I learned. And maybe that's just making my stuff get a little mixed up. Instructions could be more clear for homework. Okay, I am homework. Okay, so not labs. So I hope that this week, providing all those examples will help make things more clear. The labs are hard to get through. Videos are very long. Yes, they are. I'm very long-winded. The native video player for Moodle is bad. We're on YouTube now. It's hard to scroll through, and it's naturally very small. Oh, the video itself is scroll through. Okay. So we can't see what you're doing unless it's full screen. Other teachers have uploaded their lectures to, I'm like a little, oh, unlisted on YouTube. I should have done that. I did it listed. I'm a little paranoid about things being on Google, but it's all good. I don't know what VoiceThread is, and I don't want to know. I assume it's like an auto notation system.
It's painful and it's terrible. So yeah.
Okay, so I ain't using that. But it's on YouTube. We're all good. Like and subscribe. Smash that like button, students, and I might give you an A. Okay. We're new to this. Okay, standards. Okay. Oh, okay. Wait, let me reread that. Problem with the assignments. There's no standards to the assignments, or there's unclear standards. Okay. Obviously, I think you can tell my goal is for you to never feel stressed. It's just to get good stuff out of you without wringing it out of you. I don't want to stress you out. Yes, I agree. I couldn't find particularly good examples of a low fidelity prototype that wasn't in video form, but now I have one. I provided it. I do have previous streams that I do teach about lighting in Unity, like pre-rendered lighting and path navigation, like having an AI move from point to point. If you're interested, Lexi, they're all on YouTube. You've been stuck in classes where everybody's been in teams. Okay, yeah, so here's a serious question. I have this group project. We'll let out by 10:30, by the way, don't worry. We have group classes or a group project, but not everybody is in a group, but they want to be in a group. How do other classes facilitate getting you into groups? I think I asked this before and y'all said, oh, we just kind of do it. But is it always a free for all? Like nobody has ever used some program to help you get there. Like, oh, here, I made a survey. Everybody do it. Okay. I was looking around online. I didn't see something that existed where I could like put a list of students and then just say like, oh yeah, everybody drag in where you want to go. You pick teams. Okay, so let me put this in session planning. I mean, that's a thing, but the problem with that is then all the artists end up with all the artists and all the programmers end up with all the programmers. And then like it makes difficult collaboration when everybody has the same skill set. As long as you have a diverse skill set, that's cool. But if everybody kind of silos themselves, then inherently neither side can get as far as if they were working together. My group is like, we're all in a different part of the game thing. Okay. And everyone, please list your teams here and discuss with one another about teams if you don't yet have one. We'll keep this channel to group discussions this week until we have everything sorted out. Alex, who's not here? Alex, is Lee here? I'll tag them. don't see Lee. At Elizabeth, Liz? Oh, yeah, Liz. Okay. Is anybody already working with Lee? I know that some of you are already friends with them. And Alex.
Kendall and I were gonna work with Lee then.
Okay, cool. And the stress before sending a message sent. Okay. Okay, so I hope that my changes to the assignment format this week reduces this stress of like knowing what I'm looking for. I hope that the YouTube stuff helps. Not a fan of coding. Can't help with that. I'll try, you know, as we go into the group project. Hopefully that means that if you're not a fan of coding, you're working with someone who is, and they can handle that stuff and you can handle your stuff and everything's good. But there is a slight amount of coding that is helpful to artists in general if they just want to make things happen. And I'm just trying to get you there. You know, I hope that I haven't gotten too into the weeds on some of the inner nose itch. I haven't gotten too into the weeds in that stuff. If I do, stop me and tell me this lab is crazy and don't do it like this. But I'm trying to at least show like, oh, this is how you do touch inputs in Unity. This is how you do tilt reading, like if you want to do a tilt game. Maybe I'll do like, this is how you spawn an enemy or like spawn a little thing that the character can hit. I don't know. I'm getting a lot of YouTube requests. Well, that means I've met a lot of requests. Labs are very challenging. Yeah, it's useful, Mercy, but I understand the perspective that providing all that additional context in a video in the lab also obscures what it is you're supposed to do in the lab, because sometimes, you know, I'm doing it along with you, sort of. So I'm just kind of YOLOing, making something happen. And along the lines, I'll go, oh, actually, you know, that's not exactly the best thing to do. I'll do it like this instead. So then the person following along goes, oh, I got to delete all that stuff and then I got to do it again. It's definitely a problem that I realize, but it's also because I'm making it at the same time. So then like halfway through the lecture, I go, oh, maybe I should change a few things to make it nicer. And then I make it nicer, but now everything's weird because then the rest of the lab exists that you've already followed through. So in this lab, I've created a finite set of steps in text form that you can follow before jumping in, and I provide the code. So hopefully that makes things less torture to listen to my voice for an hour. I've already gotten you guys for 2 hours here. Okay, so the lab video has been very challenging. I agree. Too many digressions. I agree. Laying out steps that are taken. Yeah, life's a journey. So are my videos. I gotta be better about that. The shorter video that helped with part 1 of lab 2 would be much better. So maybe I'll try to also like create the quick versions of each one after I'm done. NA, great. And the labs take long. Well, this lab is about half as long as the previous ones. Maybe I'll make a part 2 that's optional. Like, oh, if you want to have some enemy spawn or whatever, this is what I do. Or like, what do we want to see about Jumpy Cube? Maybe I'll add limitations for moving left and right. Maybe I'll do that. But cool. That's it. That is my review of the surveys. I was reading one more time. Cool. And let's pop back over to the, is there anything I missed? Did I talk about the lab and did I already talk about the assignment?
Yeah, you did.
Okay, cool. So I believe that means we can close for the day. And I'll move all subsequent classes to 9 a.m. because we finished. I just need to be done by noon. That's when my class starts. Or not my class. That's when my work starts. So, I did so today with, an hour and a half of breathing room. So that's plenty. We'll move it to 9 a.m. If that's better for everybody. I see a woo. I see a yes. I see a happy face. So I'll say officially. Oh, of course, Sarah. Yes, cool. Okay, I'll do a little announcement here. Oh, what's that weird spinning toad gif? I did not see that. At everyone, we will be meeting at 9 a.m. on Fridays from now on instead of 8:30 for people's sanity. Hey, wait, is this just a weird way to make it so that you have a half hour longer to turn in your homeworks? I see through your ruse.
I would never wake up early.
We start at 7:30 now. Oh yeah, no worries. Yeah, okay.
Like a minute before class starts.
No, God, please. I remember I used to have to get up at 5:30 a.m. for one of my classes at Drexel. That was the worst. Because I liked having breakfast beforehand, so I'd go to breakfast and then class at 7.
That sounds awful. What the hell?
Because I used to have a thing where like I would not go to class if I didn't yet eat breakfast. It used to be like a thing.
I mean, I'm the same way, so that's valid.
Yeah. So, okay. At everyone. That is officially in place. Now, anybody, I can do breakout rooms now. Sarah, do you want to go into a breakout room for a discussion? Actually, I won't figure it out. I know technically I can do it. Oh, it's not enabled now. Weird. Shucks. Okay. So, everybody who doesn't want to be here, get out of here. Anybody who wants to talk to me after class, it is now officially after class.